Now, if x equals secant xn, that converges to x. Z equals Zn be a sequence of real numbers, non-zero real numbers. Secant Zn is a non-zero real numbers. That's the crucial point here. Non-zero real numbers. Then, such that it converges to such. Zn converges to such. Xn converges to x and Zn converges to such. If z differs from 0, then x by such. When z differs from 0, then x by such converges to small x by small such. When xn converges to x means secant x equals xn converges to x. Secant z equals secant zn converges to such, where that's a sequence of non-zero reals. Why? Because of the existence of this one. So x by z converges to x by z. How? Or xn by zn. Simply, or means this is xn by zn converges to x by z. How to prove this one? Given proof is, suppose zn, what is zn? Zn is a non-zero real sequence of non-zero real numbers. Zn differs from 0, also z differs from 0. Yes. Now first we prove 1 by Zn converges to 1 by z. This is our first aim. 1 by Zn converges to 1 by z. So for consider modulus of 1 by Zn minus 1 by z. What is 1 by Zn minus 1 by z? By taking LCM, it is z minus Zn divided by z into z. Z minus Zn by z into Zn. More precisely, mod z minus Zn divided by mod z into mod Zn. Why? Because mod A by B is same as mod A by mod B. Also model CD equals mod C into mod B. Okay. Right. Now Zn converges to such. Given. It is given Zn converges to such. That means for all epsilon is positive, there exists or some epsilon is positive, there exists k1 following n such that modulus of Zn minus h, mod Zn minus h strictly less than mod z by 2. Mod z by 2. Why? What is z? Z differs from 0. There is a sequence of non-zero real numbers. So mod z is also a positive quantity. Mod z by 2. So which is taken as some epsilon. Epsilon is mod z by 2. Okay. Mod Zn minus h, but we know that. We know that mod Zn minus mod h, which is less than or equals modulus of Zn minus h. Why? This is because of the idea mod A minus mod B less than or equals modulus of A minus B. Okay, modulus of A minus B. So that means mod Zn minus mod h less than or equals, but what mod Zn minus h? Strictly less than mod z by 2. Okay, so it is mod z minus, or before going to instead of this one, or mod Zn minus mod z, or simply what is mod z minus mod Zn? This is also this way. So mod z minus mod Zn less than or equals modulus of z minus Zn. That means mod z minus mod Zn less than or equals mod z by 2. From here, mod Zn minus z is less than mod z by 2, or mod z minus Zn less than mod z by 2. Okay. So that means here mod z by 2 less than mod Zn for all n greater than or equals 2. Okay. Why? Because if you bring this mod z by 2 here, that means this is from here, mod z minus mod z by 2 less than or equals mod z. Okay, mod z minus 2 equals, it is mod z by 2. So mod z by 2 less than or equals mod z for all n greater than or equals strictly inequality. Okay, so here mod z by 2 strictly less than mod zn for all n greater than or equals, here we choose k1 for all n greater than or equals k1. Moreover, Zn again converges to Z. We also know that Zn converges to Z means for all epsilon is positive, there exists some k2 for n such that modulus of Zn minus H strictly less than epsilon into mod Z square by 2. Epsilon into mod Z square by 2. Epsilon is sufficiently small. This is again positive. So it is epsilon into mod Z square by 2. And for all n greater than or equals k2. Okay. So again put up k equals maximum of this k1 and k2. So these two results are held for all n greater than or equals k. Agree. So now again come to here. Come to this one. From equation A, it is modulus of 1 by Zn minus 1 by Z, which is equals mod Z minus Zn. What is mod Z minus Zn or mod Zn minus Z? Which is strictly less than epsilon into mod Z square by 2 divided by mod Z into what is mod Zn? Here mod Z by 2 less than mod Z. Come to this argument. Mod Z by 2 less than mod Z. Mod Z by 2 less than mod Zn means what is 1 by mod Zn? 1 by mod Zn less than 2 by mod Z. Okay, so into 2 by mod Z. Listen, epsilon mod Z minus Zn from here. Mod Z minus Zn or mod Zn minus Z less than epsilon into mod Z square by 2. Epsilon into mod Z square by 2. On denominator, it is mod Z. Remains here. Into 1 by mod Zn. There is a mod Zn also on denominator. But here we have mod Z by 2 less than mod Zn. So what is it's a reverse inequality. Means 1 by mod Zn less than 2 by mod Z. Okay, take a reciprocal. Sorry. So 2 and 2 cancelling each other, mod Z square cancelling each other equals epsilon. That means, so from here 1 by Zn converges to 1 by Z. Okay. Now we prove we have Xn converges to X and Zn converges to 1 by Z. So, 1 by Zn converges to 1 by Z. Therefore, what is Xn into 1 by Zn? Xn into 1 by Zn converges to X into 1 by Z. Why? Because when Xn converges to X and Yn converges to Y, Xn Yn converges to X Y. Instead of Yn, here we choose 1 by Zn. Instead of Y, here it is 1 by Y. 1 by Z. So, here first we prove 1 by Zn converges to 1 by Z by using these arguments. And then we use a result. When Xn converges to X and Yn converges to Y, then X and Yn converges to X, Y. So here Xn into 1 by Zn converges to X into 1 by Z. Okay, so this is our next interesting result.